All right, so for absolute value, we are going to solve equations that have the absolute value symbols. So if you guys aren't familiar with your absolute value symbols, they literally are just two bars, okay? And inside those, there might be a number, there might be an expression with a variable. It could be anything in there. But first thing you need to understand is what the concept of absolute value is. And all of our equations today should have two different answers. And I'm going to tell you why in just a second. It has to do with the definition of absolute value. Okay, so it says, what is absolute value? This symbol, so here it is again. And if I were you, you don't have to be like super exaggerated with it, but you don't want those bars to look like ones. So just make sure you extend them so that they're bigger than whatever's written on the inside. Okay, because you don't want to confuse it with like a 1. This symbol represents the absolute value of the number x. Absolute value of a number is the number of units it is from 0 on the number line. Okay, so if I asked you right now, what is the absolute value of positive 5, what would you tell me? It's 5, right? Because it's 5 units away from 0. And then if I said, what's the absolute value of, there's not a tick mark there, but what is the absolute value of negative 5? Well, isn't that still 5 units away from 0? And we don't ever say, like, go negative 5. We say just go 5 to the left. So whether it's a positive 5 or a negative 5, they are both the same distance from 0 on a number line. That's why we're going to have two solutions, because we can have both the positive and the negative as our answer. Okay? So that was just the example they showed. It said 5 and negative 5 have the same absolute value. Go ahead and turn the page. And we're going to just practice some absolute value problems here. They went ahead and told you, like, the absolute value of negative 8 is 8. The absolute value of 4 is 4. So what would the absolute value of 15 be?
15.
Okay, 15. What's the absolute value of negative 23?
Negative 23.
It's just 23. And when you find absolute value, there should not be any bars anymore, right? Okay, now this one's a little different. This one says, find the absolute value of 9 first, which is 9, and then make it its opposite. Remember, whenever there's a negative sign in front of something, that typically just means opposite of that. So if the absolute value of 9 is 9, what's the opposite of 9? Negative 9. And then you have to treat absolute value symbols almost like a grouping symbol. Whatever's on the inside has to be done first, and then we'll take the absolute value of that. So what's 5 plus negative 8?
13.
Negative 3. And then what's the absolute value of negative 3? Positive 3. Okay. All right, then down here at the bottom, it says we can evaluate expressions that contain absolute value symbols. So think of these bars as grouping symbols, and they want us to evaluate the absolute value of 9x minus 3 and then plus 5. They give us the value of negative 2, so of x. What am I going to do with that negative 2? What am I going to do with that negative 2?
Multiply it.
We're going to plug it in, right? We're going to plug it in where the x is. So I'm going to just rewrite this for now. Plugging in that negative 2. And then we need to start in here What is 9 times negative 2? Negative 18. And what would negative 18 minus 3 be? Okay, so negative 21 is what goes inside those bars. And now we can figure out the rest. What is the absolute value of negative 21? Okay, 21 and then plus 5, which is 26.
Wait, I thought a negative times a negative is
We're not multiplying. We multiplied those two to get negative 18, and then we subtracted 3. All right, now, up to this point, we haven't done any equations yet. That's just an expression. So as soon as you turn the page, these are the types of problems that you are going to be solving today. Okay, so a couple things, couple steps that you just need to understand and be aware of. It says when we have equations that contain absolute value expressions, the very first thing you have to do is you have to get the absolute value expression by itself. When they say isolate it, that means if there is something, so look up here, if there is something in front of these bars, like over there, I'd have to move it first. If there's something behind it, like a plus 5, minus 6, whatever, I'd have to move it to the other side. Or if there's something underneath it, like let's say it's the absolute value of something divided by 4, I'd have to get rid of the divided by 4 first before I could even think about solving this problem. Okay? So, look at this example. Are those bars already isolated? Like, is there anything in front of it, behind it, or underneath it? No. So they're isolated already. Okay? So this one is about as easy as it gets because you don't have to isolate it. What you do have to do is just think of this. So if I were to cover up this expression, like if you guys could not see what was under my fingernail, this says the absolute value of something is 3. Well, what number is 3 units away from 0? 3 and negative 3. So whatever's under my fingernail could equal a positive 3 or it could equal a negative 3 because both of those would have an absolute value of 3, right? Okay, so this is what you guys are going to do. As soon as you have these isolated, you are going to break this up to 2 separate equations. The expression in the bars never changes. You do not change the x plus 8. Both of them are going to start with x plus 8. What will change is what they're equal to. One of them could equal a positive 3, or the other one could equal negative 3. Now, how do you solve those 2 equations? Don't you just subtract 8? We're solving them both the same way. Will they both get the same answer? No. They should not get the same answer because we don't have, right, they were opposites of each other. Now, your answers won't even be opposites of each other. Like usually, it's not like you're going to get a positive 10 and a negative 10. Now, you might, depending on what kind of problem it is, but what is 3 minus 8? Negative 5. And then what is negative 3 minus 8? Negative 11. Now, remember, until Sherry Lynn messages us saying that we are clear, we cannot leave this room, okay? Just keep that in mind. Or just you can't leave, period. All right, is everybody okay with that? Now, Ivy Tech people, dual credit people, and they're really trying to get Algebra 2 students to start using that set notation. I prefer to leave my answers written like this. You might, on an answer key, see these two answers in set notation, just like we did with that sample space, those brackets are just telling you what are, what the possible answers are. So I'd put the smaller one first, then the other one. You might want to try to just start using set notation. Like I said, I like to leave my answers like this, but just in case you guys see answers on an answer key like this, just know that these are the two answers you should have gotten. Okay? You guys feel okay with that first one? Like I said, they don't get any easier than that because the bars were already isolated. Okay, then let's try, we've got two problems down here. Let's take a look at the one on the left. What number do I need to move? Yeah, I have to get rid of this 9 because in order for these to be by themselves, I can't have anything underneath it. So if they've divided by 9, what do? We're going to multiply both sides by the 9. All that does on the left-hand side is get rid of the 9, right? Are my bars gone yet? No. So we're going to just bring down the absolute value of 6x minus 6 equals, and then what's 4 times 9? 36. Now are the bars isolated? Now we can break it apart, right? We can write our two. Here's like one equation, here will be my other one. What's my first equation going to say? 6x minus 6 equals 36. No bars, right? My second equation is going to start out the same way. It's still going to be 6x minus 6, but it's going to equal what? Negative 36. So now you guys can go ahead and solve both of those. Those are just two-step equations. Add 6 to both sides and then finish with division. Now, I haven't gotten my two answers yet, but when I added 6 to this one, I got a 42. And what's 42 divided by 6? Okay, so my first answer should be x equals 7. And then my second one, when I added 6, I got negative 30, right? And then divide by 6. So you get negative 5. So up there at the top, I wrote my two answers in that set notation just so you guys can start getting in the habit of seeing that. Negative 36 plus 6 would be negative 30. How's that one? Is that okay? Okay. Then this one right here, I'm going to warn you about this one. And I'm not saying that you guys would ever do this, but when you guys look at this, there is a number in front of the bars. anytime people see a negative, they automatically think subtraction, and they instantly just want to add 9 to both sides. But if this number is right up against that bar, what does that actually mean? It means multiply. What is the opposite of multiplication? Okay, so before you do anything else, we need to get rid of this number, and we're just going to divide both sides by that number that's out front. I'm warning you of that because I do know on the old test, now I haven't looked at the new test yet, but on your old exam, this one, there was one always like this, and they always stuck a negative number out front to see who would remember that you should be dividing instead of adding. Okay, so then, are those bars gone yet? No, just bring down x divided by 10 inside that absolute value symbol. Oops, what's negative 9 divided by negative 9? Positive 1. Now, Brittany, because you said that, I'm gonna stop for a second. If you guys didn't hear Brittany, she accidentally said negative 1. But is absolute value of something ever going to be negative? So if this actually was a negative 1, there would be no solution to this problem. Okay? So just keep that in mind. If you ever come across one where it says the absolute value is equal to a negative, there's no solution. All right. Now, I don't think that happens on your practice page, but I want you to be aware of that, okay? So now, bars are isolated. What do?
Divide by,
Well,
multiply by 2.
got to separate them first. We got to write our two equations, right? So one equation is going to look just like this, except there will be no bars, right? It'll just say x divided by 10 equals 1. What's my second equation going to say? Equals negative 1, right? So those are your two separate equations. One set equal to the positive 1, one set equal to the negative 1. And how do we solve them? It's just one step. Multiply by 10. Remember before when I said typically you don't get answers that are just opposites of each other? This is the only time that you will get answers that are opposites because we're just multiplying. We're going to get x equals positive 10 and x equals negative 10. And then I'll do my set notation down here this time. Negative 10, positive 10. So whatever you do, do not make these brackets parentheses, because then you're talking about ordered pairs. And that's
I
not...
thought when you multiply negative by a positive, it would
It's
be-
always negative. Yeah, it does.
So what is that? Multiplication sign?
Right here,
No, on the other one.
right here.
No, on that.
This one,
Yeah, for 1 times.
that's a dot for multiplication. Yeah, sorry. Yeah, we don't use X's for multiplication because of the letter X. Okay, so far you guys have had one that was already isolated, so you got to just break it apart from the beginning. You've had one where you had to multiply to get them isolated, and you've had one where you've had to divide to get it isolated. When you turn it over to the back, it's the last problem, right? There are probably two things that we have to do before we solve. Okay, so take a look at this. Clearly, that expression is not by itself. It has a times 2 and a plus 5. Which one do I move first? The plus 5. Let's go ahead and subtract 5 from both sides. You got to bring all of this down. That has not changed yet. So 2 times the absolute value of 3x minus 1 equals, and what's 33 minus 5? Okay? And then with that 2 that's out front, how do I get rid of it? Divide. So you're going to divide both sides by the 2. So that way, now we have the absolute value of 3x minus 1 is finally by itself. And what's 28 divided by 2? 14. Okay, you guys think you could finish it from there? What do you do at this point? Now that they're isolated, what do you do? Separate it? You guys, don't forget, once they're isolated, you guys have to separate this into 2 different equations. You should not just be solving one equation. What's my first equation going to look like? Yeah, it looks the exact same, just without the bars. And what does my second one look like? Same thing, but negative 14. Now you guys should be able to finish that. It's a 2-step and a 2-step equation. Solve them both. You should be adding and dividing. And your 2 answers should not be opposites of each other. One should be a whole number, one should be a decimal. Yep. Yeah. A lot of times you'll get like with this one, you'll get 1 whole, 1 decimal. Sometimes you'll get 2 decimals. I usually leave mine written as a fraction, but I don't really care how you guys write it. Do we have our 2 answers? Cool. Here they are. First one, you should have gotten a positive 5. Second one, I would have left mine as negative 13 over 3 just because I like to leave mine in fraction form. But it's negative 4.3 repeating. So either one of those, no matter which way you wrote it, would be considered correct. So let's see, negative 13 thirds and 5. That's it in, or you can put your decimal and then the 5. But that's set notation, showing us the 2 answers. Okay, what questions do you guys have? Just don't forget, I'm always most worried about when there's a number in front, especially if it's a negative. If it's attached to those bars, you're just using division, okay? So we're going to practice some of these now.